Type the address, press enter, page shows up. The internet does it. What's left to explain?
That question, what happens when you press enter, is the most famous interview question on the internet. There's a GitHub repo that exists just to answer it. 40,000 stars.
40,000 stars for something I just did?
Because your answer was 5 words and all of them were wrong. 7 minutes from now, you'll walk the whole journey, step by step. This is Sticks It Out.
Stars mean nothing.
Here's the one-sentence version. When you press enter, your browser runs a 4-step errand. Find the address, open a line, place an order, and build the page itself.
Build? The page already exists somewhere. It just downloads.
That's the exact myth this video kills. Nothing you're looking at existed before your browser built it. And here's why you care. Every slow page you've ever cursed at is stuck in one of these 4 steps. Find the step, and you found the fix. Picture it like ordering from a restaurant you only know by name. No address, no menu in your hand. Just a name, Sticko's Food. First problem, you know the restaurant's name. Delivery needs an address. Computers have the same problem. Sticksit.out.com means nothing to a network. Networks route numbers, IP addresses. Something has to turn the name into a number.
No, it doesn't. I type the website and Google finds it.
That's the search bar. This is the address bar. Different job. And Google is a website too. Something had to find its address first. That something is DNS, the internet's phone book. Your browser checks its own notes first. Then it asks your operating system. Then a resolver, think of it as a concierge your internet provider runs. If the concierge doesn't know either, he asks up a chain. The root servers, the .com servers, and finally the server that actually owns Sticksit.out.com. Back comes a number, something like 203.0.113.7. Uncached, that trip costs maybe 20 to 120 milliseconds. Cached, it's basically free. Either way, nothing else can start until it's done. So now we've got the address. But knowing someone's address doesn't mean you're talking to them. How do 2 machines agree if a conversation is even happening? Time to call the restaurant. But the internet has a dirty secret. It loses things. Internet talks in packets, and packets vanish. Arrive twice. Arrive out of order. So before any real data moves, both sides run a 3-step check. Your machine says, hello. The server says, I hear you. Do you hear me? Your machine says, loud and clear. That's the TCP handshake. Now both sides know the line works.
Skip it. Just yell the order into the phone. Faster.
Yell into a line that might be dead? You'd never know if the order arrived. Some things do work that way. Video calls drop lost frames and keep going. But a web page can't show up missing chunk 3 of 5. Then one more layer. That padlock in your browser means TLS. You and the server agree on a secret language, so anyone tapping the wire hears noise instead of your secrets. The cost? Each handshake is a full round trip. If the server's across an ocean, that's 100, 200 milliseconds gone, before 1 byte of actual page has moved. Newer versions of the web trim this toll. They fold the reliability check and the secret language into a single exchange. But the idea stands. You pay for trust before you get data. The line's open, it's private. So what do we actually say? What does "give me the page" look like on the wire? You don't chat with a kitchen, you hand over a ticket. Structured, no small talk. That's HTTP. The request has a verb, get, as in get me something. A path, which page, and headers, who's asking, what formats you accept, what language you prefer. A precise order slip. The server sends back 3 things. A status code. 200 means fine, 404 means no such page, 500 means the kitchen is on fire. Headers, and the body.
The body being the page. Finally, the process over.
The body is text. HTML, a recipe card and a bag of raw ingredients. The restaurant didn't send you dinner. It sent you a meal kit. And the first kit points at more kits. The HTML says, also fetch this style sheet, this script, these 14 images. A typical page today fires dozens of follow-up requests and pulls a couple of megabytes. One footnote. On modern connections, the ticket itself travels as compact binary, not readable text. Same order, different envelope. So now we're standing in a kitchen full of ingredients and a recipe card. Someone still has to cook. Remember the meal kit? The cooking happens in your kitchen. This step is called rendering, and your browser does all of it. It reads the HTML and builds a frame, the DOM, a tree of every element on the page. Then CSS gets applied, what everything looks like and where it sits. Then JavaScript runs, the moving parts. Then, finally, the browser paints actual pixels.
So that's when the page loads.
Nothing loaded. Your machine cooked it. Same recipe on a smaller stove takes longer. That's why a heavy site crawls on an old phone, even on fast Wi-Fi. 1 megabyte of JavaScript may take over a few seconds just to parse and run on a budget phone. The network was never the problem. The kitchen was. The whole journey, interview version. DNS turns the name into an address. TCP opens a reliable line, and TLS makes it private. HTTP places the order, and the server answers with a status, headers, and text. Then the browser builds the page. DOM, styles, scripts, pixels. On your machine. Want to watch it happen? Open DevTools, Network tab, reload any page. Every step we just walked is sitting right there with timings. DNS, connect, TLS, response, render. This week, find your slowest step. And here's the part that surprises senior devs. On a normal day, most of this journey doesn't happen. Connections stay open and get reused. DNS answers get cached at every level. Half the parts are already on your machine from last time. Your browser even starts DNS lookups while you're still hovering over a link. The journey often begins before you press enter.
So the fastest request is one you never send. Cache everything. Do nothing.
This time he's right. He's actually right. Caching is quietly doing half the work around here. How it decides what to keep and when to forget, that's the next video. This has been Sticks It Out. Don't let your brain deploy on a Friday.